Hi, I'm Sally Williams, and in this series of videos I'll be highlighting the reasons why we can no longer go on generating the kind of plastic waste that will inevitably affect the world that our future generations will inherit. Behind me here is the machine that represents the turning point in the eradication of single-use plastic. It provides industry with the raw material Marpet, and Marpet is a phenomenon that will make a significant contribution to the elimination of plastic waste. Here in Martogg's Victorian processing plant lies the key to how plastic waste, once destined for landfill, is converted into Marpet, a totally recycled raw material that can effectively be reused over and over again. And I'm with Greg Kerslake from Martogg. Hi Greg.
How you going, Sally?
I'm really well. Now I want to know all about your role here at Martogg.
Yeah, I'm the Group Manufacturing Manager, so I oversee all the manufacturing and technical aspects of the company.
Very important role.
Meted and varied, and keeps me active.
I bet it does. Now I've got a question for you. Say I've got a plastic bottle or a fruit plastic container from the supermarket.
Yep.
How does that then become Marpet resin?
Really good question. It's a collaborative effort really from everyone. So let's say if the general person puts rubbish in their bin, that will go to a waste collection centre.
Yep.
That will then, exactly right, it goes to a MRF and they'll split out the plastics and the glass and the cardboard, and that will go then into a bale of plastic.
Yep.
So it's then that bale of plastic that is then actually split out, treated, washed, granulated, sorted, heat sinked, washed again to a point of where it's clean enough for it to be reprocessed, recycled back into something like our Marpet.
Which is what you do right here.
This is a vacuuremer. So this machine is basically treating the material up through the reactors and decontaminating it. So it actually is purifying the resin.
Which is what it's all about, okay?
It has to be that, because what is happening with a lot of these recycled materials, they are going back into food contact applications.
So we're making it food grade.
Making it food grade.
And that's at a very high temperature, obviously.
Very high temperature, and this system uses high temperature and high vacuum. So what happens here is we have our hot wash flake introduced to our process. It's probably one of the most important parts of the actual process to ensure that the quality of the hot wash flake that we receive is meeting our specifications for contamination, level of cleanliness, and even the source of origin. You have to make sure that it meets all the criteria so that it can actually enter into the process under license. Once the material is loaded, we then take it through a series of rare earth magnets to ensure that we have metal detection and no foreign contaminants from metal are introduced. So it passes through a eddy current metal detector to make sure there is no more further contamination if present through the flake. The material is then actually vacuum loaded over into the process where it introduces into the first reactor, sits in there for 190 degrees for approximately an hour to decontaminate under high vacuum. Once it goes through this process, it is then introduced into the second KT reactor, again at a high temperature and high vacuum, up to 200 to 220 degrees for approximately 45 minutes to an hour. The machine then self-regulates and it actually introduces the resin that's been through these KT decontamination reactors into the screw, where it is then melted and plasticized and passed through a high level of filtration through very tight screens. So the filtration process is very important in that it will actually further remove any contamination that may still be present within the polymer melt. Very fine particulates are removed during this process to ensure that the quality of the material doesn't have any inclusions, any contaminants that may introduce into the actual finished product. So once it passes from the melt filtration system, it exits the head of the extruder. It enters into this water slide or a small cooling process, just to make sure that the polymer is going from that molten phase into more of a solid phase, so that it can actually palletize and cut this material into little small granules that is a lot easier for the end customers to handle and to use in their processes. So once we palletize this material, it is quite hot still, in the vicinity of 150 to 200 degrees. It enters into what we call the CIC, or a crystallization vessel, which actually allows the material to sit there and crystallize and homogenize further. It's very important that the temperature achieved is maintained in this vessel to ensure that the quality of the material is homogeneous throughout. Once it exits these cooling hoppers, which are designed to further crystallize and homogenize, it goes over to a classification screen. This screen is designed to remove any fine particles and oversized particles to ensure that what is passed through to the packaging system is only that of quality material to our specifications. From the sieve, it is then passed over to our packaging area, where it is then decanted into a bulk bag and ready for dispatch to our customers. Once everything is then sampled, QC passed, quality controlled, we can then put it into stores and away it goes.
So when it comes out the other end, it's basically back to its original form?
It is back to PET, but it is recycled, or what we call Marpet PET.
Brilliant.
So this
What a
whole
great
process
system.
it really is, and it's exciting because you look at where it comes from and where it's going to. It's a great story.
So it's fully circular.
Fully circular.
We are going around and around, and can it go around and around again?
Infinitely.
Love
It's
it.
inherently, and that's the beautiful thing about the PET, it's inherently recyclable. So you can get it from those point of collection points, and it gets crunched up and it gets washed and treated. We put it through this process, we extrude it back out. We can actually boost the physical properties.
All because of these wonderful vacuum machines.
Absolutely.
You've got about 3 of them here now, haven't you?
We've got 3 of them.
I'm
Absolutely.
so excited, I want to see more. Greg, can I have a look at what we're talking about?
Yeah, sure, Sally. So this is what we were talking about earlier, where it comes from the consumer as a bottle in a bale, and then what's received is this here. This is exactly what we're after. This is clean, washed PET flake. It goes in through the vacuum and goes through our extrusion process, cleans up, high vacuum, high temperature, back to a food grade Marpet resin, such as that.
Okay, so it ends up like this. the
As a
Marpet
little pallet,
resin.
yeah, and that goes to the converters, and they can do injection molding, sheet extrusion for the thermoform tubs for your fruit punnets, biscuit trays, water bottles, off to engineering resins. It's such a great product.
So step 1, step 2,
Step 3,
step 3, off to the manufacturer.
and then back to step 1 again.
Step 1 again.
Great story.
It's amazing. I would like to see the end product.
Let's ask Ben McCulloch, the product manager.
Well, the product manager, perfect.
Well, thanks, Greg, and thanks, Sally. Look, recycled PET can and should be used into all applications, but specifically, PET as a resin is a superior material and a dominant material into food packaging, so fast-moving consumer goods and so forth. Now, the beauty about recycled PET is that it can be used directly in place of virgin PET. So it's a direct substitute, so it has to be FDA compliant, which is fantastic. It's durable, you know, it's robust. It's essentially the same thing as virgin PET. You know, we're not losing any of the properties, as Greg has discussed earlier. We're rebuilding the IV, and the result of that is a piece of packaging that is, you know, of very high quality.
But how do we know it's suitable for food grade applications?
I'll actually answer that one, Sal. So this is an ARIMA licensed process technology. So this has gone through rigorous testing with the FDA. So FDA is like a governing body in the United States of America for all things food contact. So if the process is not right, this machine will actually tell us if it's not right for food contact. So there's been a lot of testing that the ARIMA and have done with FDA for surrogacy testing, putting in additives, making sure it's extractable, that the machine itself is pulling those volatiles out. So through this process, it goes through those arduous conditions, very high temperature, high vacuum again, to get to those certified levels that it has to be for food packaging.
Now, the manufacturer of this product is actually located just around the corner, and it just so happens we've got a delivery going there today. So let's jump in the truck, head over and take a look at it
We can do that?
right now.
Let's go. Thanks a lot, Ben.
No worries, I'll see you down there, Sal.
See you there. Now you've seen what goes into the manufacture of Marpet, the processes involved and the philosophy behind the technology. But that's just part of the story. In the next video, I'll be showing you how Marpet is turned into everyday items, just like this one, that will soon contain the produce that we see every day at our local supermarket.